Imagine a generator so stable, so resilient, that even when the ground beneath it shakes violently, it refuses to stop running. A machine designed not just to survive chaos, but to conquer it. For years, people have claimed technologies like this were impossible, more science fiction than engineering. Yet today, we're putting one man's invention to the test. Maxwell's earthquake-proof generator has sparked global debate, bold promises, and fierce skepticism. And now, for the first time on camera, we'll push it beyond safe limits to see whether it's truly a breakthrough, or just another unbelievable claim. Maxwell wasn't a traditional inventor. He never worked in a major engineering lab, never studied at a top university, and never had access to high-end research equipment. His journey began in a small workshop filled with scrap metal, old motors, and a relentless obsession with understanding how machines behave under stress. Earthquakes fascinated him not for their destruction, but for the mechanical patterns hidden within the chaos. He watched slow-motion footage of buildings collapsing, generators tipping over, and emergency power systems failing at the exact moments they were needed most. That frustration became his fuel. His idea didn't start with, "How do I make a generator stronger?" Instead, it started with, "How do I make a generator smarter?" He believed stability didn't come from brute force, but from balanced dynamic balance that responds instantly to motion. It was a simple concept on paper, but extremely difficult to achieve in reality. The turning point was an old gyroscope toy he found in a street market. When he spun it, the device refused to fall, almost defying gravity. Maxwell spent weeks studying how it maintained its orientation. The principles behind gyroscopic stability inspired him to create a generator that could keep running even during violent lateral motion. What if the internal components could shift, compensate, and counterstabilize the shaking? What if the entire machine could behave like one massive gyroscope? The first prototypes were unpredictable, sometimes astonishing, sometimes disastrous. One early version launched itself off the test bench, spinning violently before crashing into a wall. Instead of giving up, Maxwell saw that, as confirmation, the physics were real, but the control system needed refinement. He redesigned the internal weight distribution, added vibration sensors, and built a feedback loop that adjusted the generator's core in real time. Years later, after countless failures and revisions, he finally believed he had a working model. Not earthquake-resistant, earthquake-proof. The test site looked like a cross between a construction zone and a research lab. Heavy cables lay across the concrete floor, connected to instruments that would measure stress, torque, and power output during the simulation. In the center stood the shaking platform, a steel plate capable of mimicking seismic movements up to magnitude 8.2. It wasn't just a stress test. It was a torture chamber for machines. Maxwell arrived early, carrying the generator himself, despite its weight. It was smaller than expected, compact, box-shaped, with reinforced edges and a series of vents designed to regulate internal temperature. It didn't look futuristic. It didn't look extravagant. It looked disciplined. Every bolt, every curve, every joint seemed intentional. The team set it down on the platform, securing it with only minimal restraints. The entire point was to see if it could stay stable on its own. If it needed heavy clamps or external supports, the test would mean nothing. As the crew prepared the seismic controls, Maxwell stood quietly, hands in his pockets, watching. There was no dramatic speech, no attempt to hype the moment. He simply observed as if he'd already seen the outcome 1,000 times in his head. When the control room announced the system was ready, the air shifted. Even the technicians, trained to stay objective, leaned forward slightly. Everyone knew earthquake machines can be unforgiving. They expose flaws instantly. They don't care about hype, theories, or promises. They reveal truth. Maxwell nodded. A simple gesture. The test was about to begin. The shaking platform activated with a low rumble, simulating the kind of mild tremor that most people barely notice. The generator vibrated slightly but remained steady, humming with a smooth electrical rhythm. Sensors on the monitors showed normal output, no voltage drops, no irregularities. This was expected. Any well-built generator should survive this level easily. But still, the stability was impressive. Most machines show at least a little wobble or micro-oscillation. Maxwell's unit didn't. It looked as if it was glued to the earth. The technicians increased intensity. The tremors became sharper, faster. Still, the generator held firm. When the simulation reached the level of a moderate earthquake, the entire platform began shifting aggressively. Boxes in the corner rattled. Tools on the workbench clattered to the floor. The floor itself vibrated. The generator did something unexpected. Instead of resisting the motion, it seemed to adapt to it. The internal components subtly rotated, redistributing mass as the machine counterbalanced itself. It wasn't a static object being shaken, it was a responsive system adjusting in real time. Monitors lit up with data. Torque compensation active. Vibration damping at 92%. Power output stable. One technician stepped closer, squinting. "It's not fighting the movement," he said. "It's synchronizing with it." Another replied, "That shouldn't even be possible at this speed." Maxwell remained silent. The generator continued running without a single fluctuation. Most commercial units would have shut down automatically at this stage to avoid internal damage. But this one ran smoothly, as if nothing unusual was happening. When the shaking paused, the machine didn't rattle to a stop like ordinary devices. It slowed in perfect balance, settling calmly as if the earth itself had chosen to be still again. This was the moment everyone had come for. The control room announced the next phase, a full-power seismic wave sequence simulating a catastrophic earthquake, the kind that topples buildings, splits foundations, and sends shock waves through steel and concrete. No generator on the commercial market is designed to operate during such conditions. Maxwell's expression didn't change. The vibrations hit instantly violent, chaotic, multidirectional. The platform bucked like a living creature. Dust drifted from the ceiling. The camera rig shook despite its stabilizers. A metal toolbox slid across the room and slammed into the wall. Yet the generator stayed upright. Not only did it remain upright, it adjusted continuously, shifting its internal axis like a self-correcting gyroscope. When the ground jolted left, it leaned right. When it jerked forward, the generator compensated backward. Every millisecond, it recalculated its center of balance, and the power output, dead stable, no brownouts, no fluctuations, not a single dip in performance. The real shock came 40 seconds into the test. The platform delivered a sudden vertical jolt and upward shockwave that destroys most mechanical systems, the kind that cracks engine mounts and severs wiring. The generator absorbed the hit, shuddered for less than half a second, then stabilized instantly. The room fell silent except for the roaring machine beneath the platform. When the test ended, the generator powered down gracefully, like a machine that had simply completed a normal work cycle. No smoke, no rattling, not even a warm casing. It looked untouched. The technicians stared. One whispered, "This shouldn't exist." Maxwell exhaled slowly. "But it does," he said. Within hours, clips of the test circulated through engineering groups and disaster response networks. Some called it revolutionary. Others dismissed it as a controlled stunt until raw data was released. But the implications were impossible to ignore. A generator that could run during an earthquake could save countless lives. Hospitals, emergency shelters, data centers, and rescue operations could maintain power when everything else fails. Maxwell's invention wasn't just a machine. It was a challenge to the entire industry. A reminder that breakthroughs don't always come from billion-dollar labs. They sometimes emerge from one person who refuses to stop trying. If this test proved anything, it's that innovation is still alive in places the world rarely looks. Maxwell's generator didn't just survive the earthquake simulation, it redefined what we thought machines were capable of. Whether this technology becomes mainstream or remains a rare anomaly will depend on the next steps, the scrutiny, and the courage of industries willing to embrace something radically new. But one thing is clear: when the ground shakes and everything else collapses, a machine that keeps running can change the outcome. And today we witnessed exactly that.